The 1940s produced some of the toughest diesel engines ever built. Machines designed for war, industry, and nonstop service in some of the harshest conditions on Earth. While many technologies from that era have long disappeared, these engines survived through brute strength, simple mechanics, and engineering that prioritized durability over convenience. 8 decades later, a surprising number still run daily in locomotives, generators, workboats, and industrial sites. In this video, we'll explore 10 of these incredible power plants, looking at what made them so reliable, why they lasted so long, and how some of them continue working far beyond their expected lifespan. These engines aren't just historical artifacts, they're living proof of a time when machines were built to endure. Detroit Diesel 671, the rugged workhorse. The Detroit Diesel 671 is one of the most iconic diesel engines ever produced, known for its ruggedness, longevity, and distinctive sound. Introduced in 1938, it became a symbol of reliability in industrial, marine, and military applications. The 671 designation reflects its configuration: 6 cylinders, with each displacing 71 cubic inches, giving it a total displacement of 426 cubic inches, or about 7 liters. Despite being over 80 years old, many 671 engines are still in operation today, a testament to their engineering and durability. Designed by the Detroit Diesel Engine Division of General Motors, the 671 was part of the 2-stroke inline engine family. Unlike the more common 4-stroke diesel engines, the 2-stroke design allowed for higher power output from a smaller engine. Its roots lay in the goal of creating a dependable, compact power unit for trucks, buses, construction equipment, and military vehicles. Over time, it expanded to marine vessels, generators, and industrial machinery, earning a reputation for versatility. One of the defining features of the 671 is its mechanical simplicity. It uses a Roots-type supercharger to force air into the cylinders, supporting its 2-stroke operation. This allowed it to generate a significant amount of torque at low RPMs, which is essential for heavy-duty work. Its inline 6-cylinder configuration also contributes to smoother operation compared to engines with more complex layouts. Maintenance is straightforward, and parts are widely available, which has helped the 671 remain in service for decades. The engine's sound is another distinctive hallmark. The 671 produces a deep, rhythmic chug that is instantly recognizable to diesel enthusiasts. This diesel song comes from the engine's 2-stroke firing pattern combined with its mechanical injector system. For many, hearing a 671 startup evokes nostalgia and admiration for classic diesel engineering. Performance-wise, the 671 delivers dependable power rather than outright speed. Depending on configuration and era, it produced between 150 to 230 horsepower and torque figures well above 400 pound-feet, making it ideal for hauling, towing, and powering heavy machinery. In marine applications, it could push boats and tugs reliably for hours on end. In trucks and buses, it became a backbone engine, capable of handling the harshest conditions without frequent breakdowns. The 671 also played a significant role during World War II. It powered military trucks, armored vehicles, and even some auxiliary generators, proving itself under extreme conditions. Its reputation for toughness spread quickly, cementing Detroit Diesel's position as a leading engine manufacturer. Post-war, it found its way into civilian industries, from logging trucks to school buses, ensuring that its influence extended well beyond military use. Collectors and restoration enthusiasts still seek out the 671 today. Its simple mechanics, distinctive design, and historical significance make it a favorite in vintage truck shows, tugboats, and even hot rod conversions. Despite modern engines offering more efficiency and power, the 671's reliability and character remain unmatched in the eyes of many. In summary, the Detroit Diesel 671 is more than just an engine. It is a legend of industrial and automotive history. Its combination of mechanical simplicity, robust performance, and iconic sound has allowed it to survive the test of time. From the factories of Detroit to the high seas, the 671 has proven itself as a true workhorse, earning its place as one of the most respected diesel engines ever made. Even decades after its introduction, it continues to inspire admiration among engineers, mechanics, and enthusiasts alike. Detroit Diesel Series 110 Power That Lasts. The Detroit Diesel Series 110 is a prime example of American engineering built for endurance and heavy-duty performance. Introduced in the late 1940s, the Series 110 was designed for applications that demanded sustained power, including trucks, buses, marine vessels, industrial machinery, and stationary power generators. At a time when diesel technology was rapidly evolving, Detroit Diesel aimed to create an engine that combined reliability, versatility, and long-term serviceability. The 110 in its name refers to the displacement of each cylinder, 110 cubic inches. Its modular design allowed engineers to configure the engine from 6 to 16 cylinders, producing power outputs from 250 to over 1,000 horsepower depending on the application. This flexibility made the Series 110 suitable for everything from long-haul trucks to tugboats and industrial generators, establishing it as one of Detroit Diesel's most adaptable engines. At the heart of the Series 110 was the two-stroke design that Detroit Diesel had pioneered. Unlike conventional four-stroke engines, the two-stroke cycle allowed the engine to produce more power from a smaller package. A Roots-type supercharger forced air into the cylinders, ensuring adequate combustion and high torque at low RPMs. This characteristic made it particularly effective for heavy-duty operations that required consistent torque, such as hauling freight or pushing vessels through water. The engine was also known for its mechanical simplicity and durability. Cast iron blocks, rugged components, and straightforward maintenance procedures meant the Series 110 could operate reliably for thousands of hours with minimal intervention. For industrial and marine operators, this translated to less downtime, lower maintenance costs, and dependable performance in demanding environments. Its inline design contributed to smooth operation, reducing vibrations that could compromise machinery or passenger comfort. Marine operators, in particular, valued the Series 110 for its ability to withstand continuous operation in challenging conditions. Tugboats, ferries, and workboats relied on its torque and power to maneuver large loads in rivers, harbors, and coastal waters. In land-based applications, heavy trucks and buses equipped with the Series 110 could handle steep grades, heavy cargo, and long-distance travel without sacrificing reliability. The engine's distinctive deep, rhythmic chug became a signature of Detroit diesel engineering. To enthusiasts and operators, the sound signaled dependable power and mechanical integrity. Beyond its industrial importance, the Series 110 also played a cultural role in shaping the perception of diesel technology as durable and long-lasting. Even decades after production, many Series 110 engines remain in service, a testament to their engineering excellence. The Series 110 also contributed significantly to post-World War II economic growth. Its versatility made it invaluable in construction, transportation, shipping, and manufacturing industries. Companies relied on it to power vehicles and machines critical to infrastructure development and industrial expansion. For restoration enthusiasts today, the Series 110 is a symbol of mechanical heritage, demonstrating that engines built with robustness and simplicity can endure the test of time. In conclusion, the Detroit Diesel Series 110 embodies durability, flexibility, and enduring power. Its two-stroke design, torque-rich performance, and mechanical simplicity made it a go-to engine for the most demanding applications of its era. Whether on land or at sea, the Series 110 proved that true strength in diesel engineering lies not just in horsepower, but in longevity, adaptability, and reliability. Its legacy continues to inspire admiration among engineers, historians, and diesel enthusiasts worldwide. Alco 539T, Locomotive Legend. The Alco 539T is one of the most iconic diesel engines in the history of American railroads, representing a pivotal moment in the shift from steam to diesel-electric power. Developed in the 1930s by the American Locomotive Company, ALCO, the 539T powered some of the first generation of reliable diesel-electric locomotives, helping railroads increase efficiency, reduce operating costs, and expand freight and passenger services. Its engineering excellence and versatility made it a backbone of mid-20th century rail transport. The name 539T reflects the displacement of each cylinder, 539 cubic inches, with later versions featuring turbocharging, indicated by the T. The standard configuration was an inline six-cylinder engine, producing between 800 and 1,200 horsepower depending on its version. The engine's mechanical design emphasized smooth operation, continuous power output, and durability, qualities critical for locomotives tasked with hauling heavy loads across long distances and challenging terrain. One of the 539T's most remarkable features was its robustness. Alco engineers designed the engine with cast-iron blocks and precision-machined components that could withstand the stresses of continuous operation. Its fuel injection system was reliable and precise, ensuring efficient combustion over long hours of use. Unlike steam locomotives, which required frequent maintenance, water stops, and significant manpower, diesel-electric locomotives powered by the 539T could operate longer with less downtime, dramatically improving railroad efficiency. The engine powered a generator that supplied electricity to traction motors attached to the locomotive's wheels. This diesel-electric system allowed for better power distribution, smoother acceleration, and reduced wear on mechanical components. It also enabled engineers to control torque more precisely, which was crucial when moving heavy freight cars or ascending steep grades. For the first time, railroads had an engine capable of delivering consistent, reliable performance without the labor-intensive requirements of steam engines. The Alco 539T was also versatile, extending its usefulness beyond locomotives. It was adapted for marine applications, industrial machinery, and stationary power generation. Its ability to deliver sustained torque and power made it ideal for applications that demanded reliability under continuous load. Maintenance was relatively straightforward, which made it suitable for a wide range of operators, including those in remote locations or industries where downtime was costly. During the mid-20th century, the 539T became a symbol of modernization in rail transport. It allowed railroads to replace steam engines gradually, cutting fuel costs, labor expenses, and operational inefficiencies. Freight trains became more reliable, passenger services smoother, and railroads more profitable. The engine's steady, rhythmic sound became emblematic of diesel locomotion, replacing the hissing, chugging noise of steam and signaling a new era of technology and progress on the tracks. Today, the Alco 539T is celebrated by rail enthusiasts and historians alike. Preserved locomotives still operate on heritage railways and museum tracks, demonstrating the engine's durability and historical importance. Its mechanical simplicity, reliability, and rugged construction make it highly valued for restoration projects, and it remains an object of fascination for engineers who admire its design and longevity. In essence, the Alco 539T is not just a diesel engine, it is a locomotive legend. Its combination of power, durability, and operational efficiency transformed American railroads, helping usher in the diesel age. Decades after its introduction, the 539T continues to stand as a benchmark of mechanical reliability, engineering innovation, and historical significance. Its legacy is a testament to the ingenuity of ALCO engineers and their vision for a more efficient, reliable, and modern rail system. EMD 16-184A Wartime Marine Diesel. The EMD 16-184A is one of the most powerful and durable marine diesel engines developed during the 1940s, designed specifically to meet the demanding requirements of World War II. Built by General Motors Electromotive Division, EMD, the 16-184A was engineered for naval vessels that required reliable, long-lasting engines capable of operating continuously under the harshest maritime conditions. Its design represents a pinnacle of mid-20th century diesel engineering, combining immense power, robust construction, and operational flexibility. The engine's designation, 16-184A, indicates its V16 configuration with each cylinder displacing 184 cubic inches, resulting in a massive total displacement of nearly 3,000 cubic inches. This arrangement allowed the engine to produce over 2,000 horsepower, enough to drive medium-sized warships, tugs, and auxiliary vessels efficiently. The V16 layout was selected to optimize space within engine compartments, while ensuring smooth operation and consistent torque output, crucial for vessels performing long missions or operating under heavy loads. The 16-184A was a 4-stroke diesel-electric engine, meaning it powered a generator that in turn supplied electricity to propulsion motors. This diesel-electric system offered superior flexibility and reliability compared to direct-drive engines. It allowed vessels to vary their speed without overstressing the engine, and provided redundancy in case of generator or motor issues. The engine's design emphasized reliability in extreme conditions, with cast-iron blocks, reinforced pistons, and a precisely engineered fuel injection system capable of handling long hours of continuous operation. Maintenance and serviceability were critical requirements for wartime marine engines, and the 16-184A was designed to meet them. Its components were accessible for at-sea maintenance, a necessity when ships were deployed far from repair facilities. Crews could perform repairs or replace parts with minimal downtime, ensuring vessels remained operational during extended missions. This reliability made the engine indispensable for the U.S. Navy and Allied forces, where mechanical failure could have catastrophic consequences. The engine's performance characteristics also contributed to its legendary status. It delivered a deep, resonant mechanical pulse that became recognizable to naval engineers and crew alike. Its high torque at low RPMs allowed vessels to maneuver large loads efficiently, whether towing other ships, carrying cargo, or maintaining position in challenging sea conditions. Despite its size and power, the 16-184A was also surprisingly efficient for its era, balancing fuel consumption with maximum operational output. After World War II, the EMD 16-184A found a second life in civilian maritime applications. Ferries, tugboats, and industrial vessels adopted the engine for its proven reliability and longevity. Many units continued operating for decades, demonstrating the engine's ability to withstand continuous use in harsh environments. Restoration enthusiasts today prize the 16-184A, not only for its technical merits but also for its historical significance, representing a time when engineering had to meet the dual challenges of performance and wartime urgency. The EMD 16-184A also serves as a reminder of the engineering mindset of the era, building machines to endure extreme conditions while remaining serviceable and reliable. Its legacy extends beyond military service, influencing post-war marine diesel designs and setting a standard for durability and power. The engine's combination of strength, operational flexibility, and resilience has cemented its reputation as a wartime legend, respected by engineers, historians, and marine enthusiasts alike. In summary, the EMD 16-184A is more than just a diesel engine. It is a symbol of wartime ingenuity and marine engineering excellence, Its immense power, durability, and adaptability made it indispensable during World War II and invaluable in civilian maritime service. Even today, preserved examples serve as a testament to the ingenuity of EMD engineers and the enduring legacy of mid-20th century diesel technology, demonstrating that true engineering excellence can withstand both the stresses of war and the passage of time. EMD Model 40, Twin 671, Locomotive. The EMD Model 40 is a unique chapter in the history of American diesel locomotives, notable for its innovative use of twin Detroit diesel 671 engines. Introduced in the late 1930s and produced in limited numbers, the Model 40 was designed primarily for switching duties in rail yards and short-line freight operations. Its combination of compact size, twin-engine design, and reliable Detroit diesel power made it an efficient and practical solution for smaller railroads, industrial facilities, and shipyards. The Twin 671 designation reflects the locomotive's use of two inline six-cylinder Detroit diesel 671 engines, each displacing 426 cubic inches and producing approximately 150 horsepower. By pairing the engines, the Model 40 could deliver around 300 horsepower, a modest figure by mainline standards but more than sufficient for switching tasks. The use of two smaller engines instead of a single large engine was an innovative approach that allowed for easier maintenance, improved redundancy, and a compact design suitable for confined rail yard operations. The 671 engines used in the Model 40 were two-stroke diesels with a Roots-type supercharger, a proven design known for durability, torque, and simplicity. Each engine drove its own generator, which powered the traction motors connected to the locomotive's wheels. This diesel-electric setup allowed the locomotive to deliver smooth and precise control at low speeds, critical for switching tasks that required frequent stops, starts, and careful positioning of freight cars. Operators appreciated the reliability and mechanical simplicity of the twin-engine configuration, which minimized downtime and reduced maintenance costs. The Model 40's compact size was another advantage. It could navigate tight curves and confined spaces that would challenge larger locomotives. Its low axle load made it suitable for industrial tracks, light branch lines, and dockside operations where track conditions were not always ideal. Despite its small size, the locomotive could handle heavy cars over short distances, making it indispensable in rail yards, manufacturing facilities, and ports. Operationally, the Twin 671 engines offered redundancy. If one engine failed, the locomotive could continue operating, albeit at reduced power. This feature was particularly valuable in industrial environments where delays could be costly. The mechanical accessibility of the 671 engines also meant that maintenance crews could service the engines quickly, often without specialized tools, ensuring that the locomotive could return to work with minimal downtime. The EMD Model 40 is also notable for its role in demonstrating the flexibility of Detroit diesel engines in rail applications. While most mainline locomotives relied on larger single-engine designs, the Model 40 showed that smaller modular diesel engines could meet specific operational needs efficiently. Its quiet operation, mechanical simplicity, and rugged design made it popular among operators who required reliable, low-maintenance locomotives for specialized tasks. Although only a limited number of Model 40 units were produced, their legacy endures among rail enthusiasts and collectors. Preserved examples are occasionally seen in museums, heritage railways, and industrial exhibits, providing insight into an era when railroads experimented with new diesel technologies and configurations. The Twin 671 setup is a reminder of Detroit diesel's versatility and its influence on early diesel-electric locomotives. In summary, the EMD Model 40 is a testament to innovation in diesel locomotive design. Its Twin 671 engines offered reliability, compactness, and operational flexibility, making it ideal for switching, industrial, and short-line duties. While it never matched the horsepower of mainline locomotives, Its practical design and engineering ingenuity ensured that it served its purpose efficiently and reliably. Today, the Model 40 remains a celebrated example of early diesel-electric innovation, admired by engineers, historians, and rail enthusiasts for its unique twin-engine design and enduring legacy in American railroading. Alco DL-109, Diesel-Electric Pioneer. The Alco DL-109 is a landmark in American diesel-electric locomotive history, representing the transition from steam to diesel power on the nation's railroads. Introduced in the late 1930s by the American Locomotive Company, ALCO, the DL-109 was designed as a streamlined, high-speed passenger locomotive capable of rivaling the power and efficiency of contemporary steam engines. Its innovative design, combining diesel-electric propulsion with aerodynamic styling, set the stage for the dieselization of American railroads. The DL-109 was powered by a pair of ALCO 539T inline six-cylinder diesel engines, each producing around 1,200 horsepower. These engines were connected to generators that powered the traction motors driving the wheels. This diesel-electric configuration allowed for smooth acceleration, precise speed control, and a dramatic reduction in mechanical complexity compared to steam locomotives. With a total output exceeding 2,400 horsepower, the DL-109 could haul long passenger trains at high speeds while maintaining reliability and efficiency, a feat that few steam locomotives could match without significant maintenance. One of the DL-109's standout features was its streamlined body design. Unlike the bulky, exposed boilers and smokestacks of steam engines, the DL-109 featured a sleek, aerodynamic exterior, reducing wind resistance and contributing to higher operational efficiency. The design also made the locomotive visually striking, representing modernity and technological progress during the golden age of rail travel. This aesthetic appeal was particularly important for passenger service, as railroads sought to attract travelers in an era when competition from automobiles and airplanes was increasing. Mechanically, the DL-109 emphasized durability and ease of maintenance. Its diesel engines were robust, with cast-iron blocks and precision-machined components capable of withstanding continuous operation under heavy loads. The modular nature of the engines and generators allowed maintenance crews to service the locomotive efficiently, minimizing downtime and ensuring high reliability. This practical engineering made the DL-109 not only a symbol of innovation, but also a workhorse capable of daily, rigorous service on busy passenger routes. The DL-109 also played a key role in proving the viability of diesel power for high-speed passenger service. Steam locomotives required frequent stops for water and maintenance, whereas the DL-109 could travel longer distances with fewer interruptions. Its ability to deliver consistent power over extended periods contributed to improved schedules, more comfortable travel, and lower operational costs. For the railroads that adopted it, the DL-109 demonstrated that diesel-electric technology could rival steam in both the performance and efficiency. During its operational life, the DL-109 served with major railroads such as the New York Central and the Seaboard Airline, pulling prestigious passenger trains across the country. Its combination of speed, reliability, and aesthetic appeal made it a favorite among passengers and engineers alike. Although production numbers were limited, the DL-109's influence extended far beyond its immediate fleet, paving the way for subsequent Alco diesel-electric models that would dominate passenger and freight service in the 1940s and 1950s. Today, the ALCO DL-109 is celebrated by railroad historians and preservationists as a pioneering diesel-electric locomotive. Its combination of advanced engineering, aerodynamic styling, and operational reliability represents a turning point in rail transportation when diesel engines began to eclipse steam as the preferred mode of motive power. Preserved examples are rare but highly prized, standing as a testament to the vision and ingenuity of ALCO engineers. In conclusion, the Alco DL-109 is more than a locomotive. It is a diesel-electric pioneer. Its innovative engines, sleek design, and reliable performance helped transform passenger rail service in America. By bridging the gap between steam and modern diesel technology, the DL-109 earned its place in history as a symbol of progress, efficiency, and engineering excellence. Even decades after its introduction, it remains an enduring icon of the diesel revolution, admired for its technical achievements and its lasting impact on American railroads. Industrial 539T Stationary Power Survivor. The Industrial 539T is a remarkable example of diesel engineering designed for long-term stationary power generation. Developed by the American Locomotive Company, Alco, in the 1930s, the 539T gained recognition not only as a locomotive powerhouse, but also as a durable and reliable engine for industrial applications. When adapted for stationary use, the 539T could deliver consistent, heavy-duty performance over decades, powering factories, mills, and remote installations that required uninterrupted electricity. Its combination of reliability, efficiency, and rugged construction earned it a reputation as a true survivor among industrial diesel engines. The 539T designation refers to the engine's 539 cubic inches of displacement per cylinder, with turbocharged versions indicated by the T. Typically configured as an inline six-cylinder unit, the industrial 539T produced between 800 and 1,200 horsepower, depending on the setup and application. While locomotives demanded frequent acceleration and variable loads, stationary industrial engines benefited from continuous operation at steady output levels. The 539T's mechanical design, robust construction, and fuel efficiency made it ideal for such scenarios, where reliability was paramount and downtime could be extremely costly. Mechanically, the industrial 539T shared many characteristics with its locomotive counterpart. It featured cast-iron blocks, precision-machined pistons, and a high-quality fuel injection system engineered for longevity. The turbocharged versions enhanced performance, ensuring steady power output even under heavy loads. One of the most significant advantages of the 539T in industrial settings was its simplicity and ease of maintenance. Components were accessible, and operators could perform routine inspections, repairs, and adjustments without specialized equipment, reducing operational costs and extending the engine's service life. The engine's stationary applications were diverse. It powered factories during the industrial boom of the mid-20th century, providing electricity to drive machinery, pumps, and production lines. Remote mining operations and logging camps relied on the 539T to supply steady power in areas without reliable grid access. Its use in municipal and emergency power plants ensured that communities could maintain critical services during outages. The combination of durability, steady torque, and mechanical reliability made it a go-to solution for operators who required engines that could work continuously for thousands of hours with minimal supervision. The 539T's reputation for longevity is particularly notable. Many units installed in the 1940s and 1950s remained operational well into the 1970s and beyond. These engines were designed to handle long hours under constant load, and their solid construction allowed them to survive decades of industrial use that would have retired less robust engines. For engineers and operators, the industrial 539T became synonymous with trustworthiness and endurance, a machine built to last. Beyond technical performance, the industrial 539T also represents a significant chapter in the history of industrialization. By providing reliable, on-site power, it enabled factories and operations to run more efficiently, reduced dependency on steam or hydro-powered systems, and helped accelerate economic growth in various sectors. Its adaptability across industries demonstrated the versatility of Alco's diesel technology, proving that an engine designed for locomotives could thrive in stationary industrial roles. Today, preserved industrial 539T engines stand as living history. Restoration enthusiasts, museums, and industrial heritage sites showcase these engines to highlight their engineering significance and historical impact. Their continued operation, in some cases, underscores the durability and foresight of ALCO's design philosophy. In conclusion, the Industrial 539T is a stationary power survivor. Its combination of robust construction, steady performance, and ease of maintenance allowed it to thrive in industrial settings for decades. Beyond its mechanical achievements, the engine symbolizes the ingenuity and adaptability of mid-20th century diesel technology. For historians, engineers, and enthusiasts alike, the Industrial 539T serves as a testament to enduring diesel engineering and a reminder of an era when reliability and longevity were paramount in power generation. Marine 16-184A, From War to Work. The Marine 16-184A is a legendary diesel engine that embodies the transition from wartime necessity to peacetime utility. Originally developed by General Motors' Electromotive Division, EMD, during World War II, the 16-184A was engineered to meet the rigorous demands of naval operations. It powered medium-sized warships, landing craft, and auxiliary vessels, delivering reliable and sustained performance in environments where mechanical failure could have catastrophic consequences. After the war, these same engines found new life in civilian marine applications, demonstrating the versatility and enduring value of wartime engineering. The 16-184A designation refers to a V16 configuration with each cylinder displacing 184 cubic inches, giving the engine a total displacement of nearly 3,000 cubic inches. This layout allowed the engine to generate over 2,000 horsepower, sufficient to drive electric propulsion systems that powered the vessel's propellers. Its V16 arrangement was compact enough to fit in confined engine rooms while still providing smooth, continuous torque, a crucial feature for ships operating under heavy loads or extended missions. One of the 16-184A's defining features was its four-stroke diesel-electric design. Instead of connecting directly to the propellers, the engine drove a generator that supplied electricity to traction motors attached to the ship's shafts. This diesel-electric system allowed for precise speed control, efficient power distribution, and operational redundancy. In wartime scenarios, this reliability meant the vessels could continue to operate even if a single generator or motor failed, a critical advantage in combat and logistical operations. Durability and serviceability were central to the 16-184A's design. Cast iron blocks, high-strength pistons, and a finely tuned fuel injection system allowed the engine to endure long hours of continuous operation under the most challenging conditions. Maintenance at sea was simplified by accessible components, ensuring that crews could perform repairs without specialized equipment or dock facilities. This feature made the 16-184A indispensable to the U.S. Navy, where extended deployments and heavy operational tempo required engines that could withstand relentless use. After World War II, the 16-184A transitioned seamlessly into civilian maritime service. Ferries, tugboats, and industrial vessels adopted these engines for their unmatched durability, high torque, and proven track record. In commercial settings, the 16-184A excelled at towing, cargo handling, and maintaining consistent speeds in coastal and inland waters. Its ability to deliver continuous, dependable power with minimal downtime made it a favorite among operators who required engines capable of enduring long service hours with limited maintenance support. The legacy of the Marine 16-184A extends beyond its technical performance. It illustrates how military technology can adapt to peacetime needs, bridging the gap between war and industry. Its robust design philosophy influenced post-war marine diesel engines, establishing standards for reliability, efficiency, and serviceability. Restoration enthusiasts and maritime historians today continue to celebrate the 16-184A for both its historical significance and engineering excellence. The engine's distinct mechanical pulse became a signature sound in both military and civilian settings, symbolizing power, resilience, and reliability. Operators valued not only its performance, but also the peace of mind that came with knowing their vessels were powered by an engine designed to endure extreme conditions without fail. This reputation for durability is why many 16-184A engines remained in service for decades after their initial installation, often far surpassing the expected lifespan of other engines of the era. In conclusion, the Marine 16-184A is a story of transformation, from wartime necessity to civilian workhorse. Its engineering excellence, compact V16 configuration, and diesel-electric versatility allowed it to thrive in combat and commercial environments alike. More than just a marine engine, it stands as a symbol of durability, adaptability, and enduring performance. For engineers, historians, and maritime enthusiasts, the 16-184A represents the best of mid-20th century diesel technology, proving that well-designed engines can meet both the demands of war and the needs of peace. Diesel-electric switchers, yard engines of the 1940s. During the 1940s, diesel-electric switcher locomotives transformed railroad operations across North America. While mainline steam locomotives still dominated long-distance service, rail yards needed something different. Machines that could start and stop constantly, run for long hours at low speeds, maneuver tight curves, and operate efficiently without the massive maintenance demands of steam power. This need gave rise to the diesel-electric switchers of the era, small but powerful locomotives that laid the groundwork for the full dieselization of American railroads in the decades that followed. Unlike steam engines, which required large crews, heavy infrastructure, and constant servicing, diesel-electric switchers could be started quickly, operated by minimal crew, and maintained with far less effort. Their design relied on a diesel engine turning a generator, which powered traction motors mounted on the axles. This system delivered steady torque at low speeds, perfect for shoving cars into sidings, rearranging freight consists, and organizing trains before departure. The 1940s were the decade when this technology proved itself indispensable. Several models became icons of this transition era, none more influential than the switchers built by EMD, ALCO, Baldwin, and Fairbanks Morse. EMD's SW and NW series, powered by the legendary Detroit-inspired 567 diesel engine, set an early standard for reliability. These locomotives generated between 600 and 1,000 horsepower, more than enough for yard work yet compact enough to navigate tight industrial trackage. Their steady, rhythmic engine note became a familiar soundtrack in rail yards across the country. Operators loved them because they were easy to control, quick to respond, and forgiving to handle, qualities that made them ideal for constant stop-and-go switching. Alco's S-Series switchers also played a major role. Powered by the rugged Alco 539 engine, these locomotives matched EMD's offerings in durability and torque. The 539's deep, thumping idle became a trademark sound in many northeastern and midwestern yards. Alco switchers were especially known for their heavy frames and excellent traction, making them reliable in icy or uneven yard conditions. Even today, some Alco S2 and S4 units remain in operation, a testament to the strength of their mid-century engineering. Baldwin and Fairbanks Morse, though less commercially successful, added important variation to the 1940s switcher landscape. Baldwin locomotives used air-cooled De La Verne engines, known for their raw pulling power but also their mechanical complexity. Fairbanks Morse introduced opposed piston engines, a unique design that delivered high torque and distinctive sound, but required specialized maintenance. These models helped push innovation forward and demonstrated the wide range of diesel technologies being explored at the time. What made diesel-electric switchers so transformative wasn't just horsepower, it was efficiency and endurance. A steam switcher had to return to the roundhouse for coal, water, lubrication, and constant cleaning. A diesel switcher could simply idle in the yard for hours, waiting for the next move. Railroads quickly realized that one diesel-electric switcher could replace multiple steam engines in yard service, drastically cutting labor and fuel costs. This economic advantage accelerated the decline of steam and proved that diesel-electric technology wasn't just viable, it was superior. The switchers of the 1940s weren't glamorous locomotives. They didn't haul transcontinental passenger trains or headline promotional posters, but they were the backbone of daily railroad operations, assembling freight cars, organizing departures, and keeping goods moving efficiently during wartime and peacetime alike. Their impact on logistics during World War II was enormous, as railroads relied on diesel switchers to handle the massive volumes of wartime freight quickly and reliably. Today, many of these locomotives remain active in short-line service, industrial yards, and museums. Their longevity is a testament to the rugged engineering of the era. Simple, powerful, and mechanically forgiving, they continue to do precisely what they were built for: moving cars, shaping trains, and proving that sometimes the most important engines aren't the biggest, but the ones that work the hardest. In the end, the diesel-electric switchers of the 1940s were quiet revolutionaries. They didn't replace steam overnight, but they proved the future was diesel. Through efficiency, reliability, and sheer practicality, they reshaped American railroading from the ground up, one yard, one train, and one freight car at a time. Stationary 539 series, generators that keep running. The stationary 539 series diesel engines are some of the most enduring power units ever manufactured in the 1940s. Originally built by the American Locomotive Company, ALCO, the 539 straight six wasn't designed with glamour or speed in mind. Instead, it was engineered for one purpose: uninterrupted, industrial-grade power. And because of that simple mandate, these engines earned a reputation as nearly indestructible machines, generators that could run for years with only minimal shutdown time. At the heart of the 539 series is an overbuilt, low RPM design. Unlike high-performance engines that operate near their mechanical limits, the 539 runs slow, steady, and cool. This made it the ideal choice for factories, lumber mills, mining stations, and remote facilities that needed a generator capable of delivering reliable energy under harsh, unforgiving conditions. The block was extremely thick, the crankshaft massively reinforced, and the fuel system simple enough to be repaired with basic tools. That simplicity is exactly why these engines aged gracefully, while other machines from the same decade faded away. Many 539 installations were placed in environments where failure wasn't just inconvenient, it was dangerous. Remote Alaskan outposts, island communication hubs, wartime facilities, and rural industrial plants depended on these generators to run lights, radio systems, water pumps, and heavy equipment. Operators have often said that the 539 series seemed to prefer being left on continuously rather than being turned on and off. Once warmed up, these engines would hum along for weeks or even months without needing to stop. The fuel efficiency wasn't modern, but the reliability was unmatched. Even after decades of operation, many units still start right up with the iconic deep rumble of a mid-century diesel. Records exist of 539 series engines that have logged over 100,000 continuous running hours, surpassing the lifespans of multiple generations of workers who operated them. Because parts were standardized and the design barely changed over the years, maintenance crews could easily cannibalize old units or fabricate replacement components. As long as clean fuel and lubrication were provided, the engine would keep going. Another key advantage was its tolerance for dirty environments. Whether covered in dust, operating in freezing climates, or placed in facilities with heavy vibration, the 539 series rarely complained. Mechanics often joked that if the building collapses, the 539 will still be running under the rubble. Today, many collectors, museums, and industrial sites continue to operate these generators not for nostalgia, but because they still work. Some rural power stations keep them as emergency backup systems, confident that when modern electronics fail, a 1940s mechanical brute will carry the load without hesitation. In a world where technology quickly becomes obsolete, the stationary 539 series stands as a rare example of engineering built to outlive its own era. These generators didn't just power buildings, they powered entire decades of industrial growth. And remarkably, nearly 80 years later, a surprising number of them continue to turn over each morning, proving that reliability is the one feature that never goes out of style.